the former video, in the previous video, we developed a small sibling as ECS of ECS, and now we want to use it, but this time in order to deal with a new component that will be the collision component. So what I want to create is this. I will have several game entities. Okay, those will be square or cube, or not cubes but rectangles, and they will go in a direction, and when they will hit the wall they will change direction, and if they hit themselves too they can also change direction. Okay, so this will force us to check through all elements if they collide with other elements, and then to well, change the direction and yeah, under the collision for each entity. Okay, so let's do something like this. First, I want to. So I've called this rigid body. What is it? I've created a component called rigid body. And so it should tell me what is if some entities are bouncing together. But maybe I want to add some values. For instance, I could add the velocity of the body, so vector 2. And by default it would be 0, 0. And what could I add? It's not bad. It's not that bad. Okay, we could start like this. The first thing is we want to have a system where when there is a velocity to a rigid body, it applies to the position of the vector. So let's say I will create, so for now my systems are just function. Maybe in the next video I will refactor everything, but for now it's just a function. So I will create void system. Could I call it physics? Oh, yeah, physics. Update. And this will take a delta time. And here what I will do is I will just, so for each, I will just update the position of any entity with a velocity. So for all bodies, in bodies, I just want to apply the velocity. So I need to get the transform. No, it's not this one, sorry, this one. I need to get the transform, so get transform to the body entity. And then what I will do is compute a new position, vector to new position equals to this transform dot position plus the velocity. Okay, the point is because it is a array-lib class, there is nothing like vector to addition. So either I create it or for now I will just sum everything. So new x. this is a float, equals plus the velocity dot x time, actually the delta time, I don't have to forget the delta time. And the new y will be this and this. Okay. And now I just have to set the transform back again. Actually, I can equal vector 2 new x new y. Oh, I cannot do this. Oh, because the constructor does not exist. Actually, there was no constructor for this. Could I pass a copy of it like this? Yeah. So this should work. Fine. Okay, and yeah, what I will do, so I create a component. So what I will do here, so yeah, I could actually change this to get transform component player ID. And now I will get rigid body component player ID dot velocity dot x equals 100. So let's see if it's working. Yeah, I'm just updating. Where's it? Okay, here. I will have to tidy this. Yeah, I'm just updating the physics. Oh, sorry, the position, not the physics. Okay. Okay, so it's working. Okay, so now what I want to do is first I want my my physics body to bounce on the side of my screen. Okay, so maybe this should be another component actually. Yeah, I think this should be another component. Yes, I will create another component called, actually it's a bouncing. Yeah, I will create another component for that. Do I need any data for it? I just have to get the body, and yeah, I need to have actually I need the size of the screen. So let's create a new component. It will actually be really similar to this one. Screen bound. So I want to stay on the screen. This is why I call it screen bound. And yeah, I will just have a screen rectangle. Screen box is actually good. And the screen box will be 0, 0, and the resolution of my game, I'm not sure I have it somewhere. I'm not sure. No, I don't think so. I just use it when I start the engine. Okay. So let's create a new component. Oh, I actually need this function too. So I need to create, how did I call it actually? Component. Create screen bound. And I will, yes. Okay, and I will need a get screen bound. Okay, is it not implemented? It is. Okay, and I need also a vector of screen bounds. I think I might be a little dumb to do this actually. I don't need this. I just actually need a system for that. But I have also that I want here. So I don't need this. I don't need, do I need the component? Yeah, I just need to create another system that will use the rigid body. So actually this is not needed at all. So I don't need this either. I will create a system screen bound update. I will actually screen bounce because this would be bouncing on the screen. Okay, and I'm not sure, I don't need the delta time. I don't need the delta time. Okay. Fine. I just have to remove this now. And this. Okay, so this screen bouncing system what's happening? What did I do? I don't really understand what I did here. I just want to generate my definition. Okay. So what I will do is again get all bodies. Do I need the transform? So I have a rigid body. The rigid body actually should be updated. I should update my rigid body. This is a box. Okay, so this is not needed actually. This is a box. Here, this should be the size of my box, and this should be the position of my box. So I actually need to update this. So what I could do is when I update the physics, I get the transform. So I could, here I could update my body, but bounded box Yeah, in order to get this, I also need to get the sprite. So I will also get the sprite to get the size of my element. Or actually I could define it at the beginning. So here, when I create my sprite, I could also create my bounding box here. This is what I will do. So I need to add what is in place back. Okay, so I need to add a rectangle here. So when I create a rigid body, I want to pass a rectangle. This is a bound box. Let's just call it box. Okay. So now when I create it, I have it here, and I can pass it to the constructor, and I just need to update the constructor now. Okay. What is the problem here? They say it is not implemented. Which is actually the box is here. It is here actually. Oh, because I miss a comma here. And here I need box. Okay, fine. Okay, so I pass my box so that I may have my box. And at the beginning, I don't want it to be necessarily equal to the sprite size. So this is why I'm passing a box here. Here, by the way, I will actually get the size of this box, but it's not something I have to do. So here what I will do is get texture. So to player texture equals asset manager get texture player. And when I want to create my box here, I want it to be at, actually I want it to be at this position. So maybe I should do this before. So that here I can and player position. This is give me, yeah. And here I can get the player position. Goes to this. And so now I can create my box. And I suppose I need to convert this to a float. Oh, thank you, C Lion, to do it for me automatically. Okay. So I create my rigid body here, so I have its size, and I can set the velocity. I will actually also set a velocity, a y velocity, and I will accelerate this, or maybe. Okay. Okay, so I'm setting my components here. And now when I go through my system, so physics update, bouncing update, yeah, I just have to check if I go to the top of the world or not. So I need the transform again. Maybe I should copy the data, the transform data into every component. Maybe I'll do that as an optimization later. Okay. So I get the transform. Actually, what I'm doing here? I say I won't. No, I actually do not need this position. The bounding box is relative to the player, so it should be 0 here. Okay. Yeah, this is fine. So, where is it? Here, I want to check if my transform actually I will create a temporary rectangle, maybe it's the better. So rectangle box equal, and actually it can be equal to the transform dot position dot x, and this will actually be constant. Transform position dot x plus maybe the bounding box. So body dot x, the bounding box dot x. Then I do the same for y. And then I would use the size of the bounding box. Okay. Okay, so now I can check with this box if x dot, oh actually, if the bounding box, the current box, sorry, dot x plus the width of this current box dot width. So this is the screen size actually. So I need a variable for it. So int, this is a float. That's the float. Screen width will be this. I need the same for screen height. So if the box position plus width is superior to this, then actually I have not this constant because I need to move to change it. So I need to replace it. Transform.pose.x should be equal to the screen width minus this, so width of the box, and then I should change the velocity x. I should actually multiply it by -1. Well, the screen 8 is actually it's actually this. Yeah, because on my screen, when I launch the game, I have this how to say it, yeah, a black band on the side, so actually I should measure its float. How to call it? Black ribbon. Height equal this. So I should take it into account, but for the x part. And then if current box x is inferior to 0, then the position should become 0. And the velocity should be inversed. So this is for the x part. Yeah, horizontal bounce. And now let's do it for vertical bounce. So now the question I have to ask myself is, how do I want to measure that? I think I want to measure it without taking the yeah, but the point is I have to draw sprites too. So I actually have to take this into account. Okay, so this is the black rainbow height. So if the current box plus height is minus 2 times the ribbon height, so position should be reset to this, so twice, actually to this minus the height, and the y velocity should be inversed. And now if the y of the current box is inferior to the black ribbon height, the position should be reset to this black ribbon height, and the y velocity should be inversed. So let's see if this is working. Oh, actually, the velocity is not, where is it? If I use it, should be fine. Rigid body, velocity y. What's the problem, so? What is strange is it didn't even modify this. Oh, but maybe I actually didn't call this function. Yeah. I actually didn't call this function. I'm just updating something here. Was it? Yeah. Okay, this is my problem. I actually have to call those two functions: system physics update and system bounds update. Oh. So it's not working on this side of the screen. It's working here, 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 but not on the bottom side. Where's the problem? So if the y plus the height of the box is superior to... Oh, it's screen height, yeah. This is why. Problem when you're copying and pasting. Oh, twice was too much. What's the matter here? Screen height, which is... Yeah, this is not this. I didn't take... I took the black ribbon height into account, but I forgot I took it, so then I took it twice into account. Okay. Oh, nearly. Nearly. This is, maybe this is not 120? I think it is. Yeah, I don't need this to be twice, actually. It's just -1. -1, sorry. Okay, now it's good. Okay, so now it's working for this, but I want several entities and I want them to bounce each one of the other on the others. And well, let's see how I will handle the collision. So this is okay and simple to handle one system of collision. But now I have to do the same for several of them. So this will happen here. So this is a new move, a new position. So now I have to check, apply velocity. And now I have to check if they collide, and if they collide, I will give a new velocity. So I need a current box, yeah. So my current box will be my... basically new x and new y plus the bounding box size if I need it. Okay. And now I need to check if they collide with other rectangle. So what I could do is go another time through all bodies and check if there is a collision. It's not very good to do this, but I'm not sure I have better solution. Yeah, what I could do is see if there are some boxes outside and just check with them. Yeah, but this will make the algorithm lighter. But for now it will be a little long. So for now I just want to test this. Okay. So can I all other bodies? Maybe I should use iterators so that I can check I'm on the same body. Yeah, I will do something like that. So I will use an iterator instead of this. So my point is, actually I'm thinking a little. If there is a collision, maybe I would like to register the collision on a collision vector, and then only then apply the collision. And the collision should be here. The point is, if there is one collision, there is actually two collisions, because two elements will collide each time. So, and normally it would be very unlikely there are more than two collisions at the same time. Okay, if there is one collision, there are two collisions. But what we can do is each. So let's draw something. What I was meaning by if there is one collision, there are two collisions. I mean that if there is one collision, for instance, with actually I could use colors. If there is one collision between the black one and the green one, there will be a collision between the green one and the black one. But what we could do is, for each collision, we will consider the other as an other collider and only apply the physics with all the quotes I could put on this. We would only apply the physics to the one that is collided by the other. Okay. So we will still need to register a collision, and so I will create a structure in order to register a collision. So let's create here. I will separate all this in different classes when I will have my code finished. We will have a video about refactoring this. But for now, I just want to make it work. So let's create a struct collision 2D, because it is a 2D collision. Sorry. Okay, collision 2D. And in this collision 2D, I will have a rectangle, which is a bounding box. vector 2, it is velocity. This will be the current box actually. And for the other, I will have other current box, so velocity, and other velocity. This will help me to compute the new velocity. And maybe I could tell, what's the problem here? Yeah, actually, velocity. And maybe I could tell on which side I'm colliding. Not sure. Maybe the computation of velocities will be enough. Okay. We'll try something like that. So, yeah, I will create, actually I will need it here, vector of collisions. So, yeah, I need to test other bodies. So I will create an iterator. So auto equals bodies that begin. I want this different of end. Sorry. Okay. So yeah, I can no longer use this. Oh, what's doing? I need to change this. Oh, I forgot the point. Okay, fine. So now I go through all the bodies, but this time I will call it other. So this is not optimized at all. I could actually go through half of them. Maybe I could do this by taking the n minus 1 each time. Maybe I could do that. Let's see, right here. I could use the n minus ITR, for instance, if I want to check only one collision. Or let's check two. For now, let's check two. I will optimize this later again. Okay, so if ITR is equal to other, continue. I don't want to check the collision with itself. Then I need to check the two rectangles colliding. And so I need to create the other box. So the other box, and in order to get this, I need to get the other transform b2d, and I need to get the other entity, get the transform. So here I will have .pose.x and other bounding box. Here I will have y, and here we will use the bounding box. Okay, so now I just have to check the rectangles. If actually I think there is a raylib collision, check collision rect. So if current box and other box are colliding, then I would register a collision. So in order to register a collision, I would just use this and place back. And they want a collision 2D. I'm not sure this would work again. No, I just created here. Not here, sorry. So it's two rectangles and the velocities. So current box, then body, so it's called idea velocity, other box, other velocity. Okay, I suppose I should create a constructor for the collision. So let's go and find it. Collision. I'm actually not sure this is necessary. Okay. Okay, so I create my collision and it should be fine. So I create all collisions, and now I just have to manage collisions. What I want to do is, so let's say we have this collision, and let's say that, I don't know, this one is going like this, sorry. And this other one is going like this, or maybe like this. what I want is to compute an angle for this one to bounce. What I could do for now is just inversing the velocity, and it should be fine. Oh, and actually, when I'm doing this, I should pass I should actually pass a reference to the object, because I need to modify, or at least to the body, so, because I need to modify it. So I must add this. Okay, so now I need to pass it also as a parameter. Yeah, this is working actually. I don't need P here. Okay, and import this. So here I have to pass my body. And to pass other. Okay, fine. So for each collision I will just inverse the speed. I won't do any complex calculation for now. Inverse the velocity. So collision dot body dot velocity. Actually I need to divide this. Collision dot I could use the other velocity. I'll do this later. Actually minus this. We'll create a more accurate physics system later. Okay. and that's all. This is all what I need to do. So this is called, and now I just have to create more objects. So here I create my entity, I create a transform, a texture, so I will create a function just to generate something like this easily. So create random bouncing entity. I actually need to do this and then copy this. Okay, and now I just need to change this. So I will use random. I think there is a random function. I get random value between 0 and, I don't know, this. Yeah, I need to convert this to float actually. Same here. And about the position, it will be quite similar. X can be between 0 and, actually, I want it to be on this side. And Y can be between yeah, this and this should be fine. Oh, actually not, because I have to take this size into account. So it's a random value. Okay, and now I will just call this function several times. Let's see if this is working. Okay, seems to work, but they are a little, maybe that's too much. Can't see it's working, but they are locked together. Okay, so maybe let's create less of them. Okay, it's working. So when they created at the same place, they are created. Maybe I should try to get them outside of their own bounds, because they can lock this way. Oh, but to do this I will need to update the transform. So maybe I should only give the entity number. Yeah, I think. So I will change this. I don't want the body here. I actually just want the entity number. So okay. Yeah, I need to change my what I need is entity ID and the entity ID too. And so here I need to get so what? Yeah, here I need to get the component, the body component. And I will get the transformed. Okay, and I want some dot position dot x. So it will actually, I want to get it outside. The point is, it's not easy to know on which side I am. Maybe what I could do is I could subtract both. Okay, I could subtract the position. Oh, but actually I have the position. Actually I have in the collision, I have the current box dot x. So I can get so just to explain to you what I want to do. So again, my schema. Let's say we are in this situation. Here I have this box and I have this box. So what I could do is check the difference between the X position here and this. Check it is the size of actually the sum of the size of the two boxes, and maybe try to put each boxes like halfway in. Actually this one should go halfway in this direction and this one should go halfway in this direction. Maybe it could be enough. Or I could just, because I have a velocity, and this velocity gives me the direction they're heading to, so I'm sure that if I move them away from this velocity times 2, for instance, I'm sure that they won't connect anymore, times the delta time. I actually have the delta time here, so it may work. It will be way more easy, I think, to do something like this. So I need to do this. Actually, I already have inverted the velocity here, so I can just reuse this. Let's try something like this and see if it prevents them from colliding. Actually, I don't want to enter too much into details, because what I've done now is just a simple way to handle collisions, and I wanted to show you how to do it with an ECS. But here I'm just trying to make it work, but I'm not sure it's really useful. I will create something more complex later. So it's not that bad, but some of them have started being connected. You see they cannot lock anymore, so it's my way of doing it. It's not that bad. Maybe just when I create them, oh no, I don't want to do that. Yeah, only the ones that are created at the same place. So I would just create a little less of them, like 15th. Okay, here we have our player. Okay, so now you see it's working. So what is interesting with this system is that it's very, how to say it? Yeah, it's very light for the computer to compute, and you can add a lot of elements if you want. So, and this is what I want, because I may have a lot of projectiles and everything, so I want to be able to get all those elements working together and being managed independently. This is a big strength of this ECS pattern. Everything has to be managed independently, and so you create a system, and your system is running, and then later you insert a player in the system. So this is really a way of thinking about a video game I like. So this is why I'm using this ECS pattern. Okay, so it seems to work well. So again, my physics is really simple. I just wanted to, so actually, do I need the transform? Yes, I need it, and I need the body. So yeah, not bad. I could actually transfer those values to the collision. It won't be, well, I'll do this later. Okay. So I'm quite happy with my ECS. It's working. I can create complex behavior, let's say, and it should be really also, how to say it, yeah, efficient actually. So yeah, that's fine for it, and maybe in the next video we'll refactor everything and put this out of the sim game. So see you later, bye.